Good morning. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. So today my topic is smoothing spatial filters. So we are going for the definition of smoothing spatial filters. So smoothing spatial filters is used for blurring and noise reduction in the image. Blurring is pre-processing steps for removal of small details, and noise reduction is accomplished by blurring. Types of smoothing spatial filters: linear filter, that is a mean filter, and order statistics filter, that is a non-linear filter. So in the spatial filters, already in the previous we discussed, spatial filters are two types: smoothing and sharpening. So smoothing spatial filters, sharpening spatial filters. So in this, first we are discussing today smoothing spatial filters. So smoothing spatial filter is one type of spatial filters. So smoothing filter is used for blurring and noise reduction in the image. So blurring is pre-processing steps for removal of small details, and noise reduction is accomplished by blurring. So types of smoothing spatial filters are two types. First one is a mean filter, another name is a linear filter. Second one is a non-linear filter. It is also called order statistics filter. So suppose I am taking one image. The input image has a noisy. So what is a noisy means? It is a blurring plus noise is there. So the blurring and noise is there. So what is the output? So the output image is a noiseless and remove blurrings. So we have to remove the blurrings and remove the noise in the output image. So smoothing spatial filter is used to remove the blurry and noiseless. So it is the concept of smoothing spatial filters. So how we are removing the small details of noise and reduction of blurring. Okay. So we have two types: mean filter and mean filter, that is a linear filter. Another is a non-linear filter, that is a order statistics filter. So what is a mean filter? Mean filter is nothing but it is a linear spatial filter, is simply the average of the pixels, and it is contained in the neighborhood of the filter mask. And the idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask. So the linear spatial filter, already here, the linear spatial filter, that is a mean filter. So the linear spatial filter is simply the average of the pixels contained in the neighborhood of the filter mask. And the idea is replacing the value of every pixel in an image by the average of the gray levels in the neighborhood defined by the filter mask. And it is multiplied by a higher value than the average value. Why? Because here I am taking mean. So multiplied by higher value of the average value I am taking here. So types of mean filters. What are the types of mean filters? Average filter, weighted average filter are the subtypes of mean filter, and another one is a order statistics filter. So what is a mean filter? What are the types? So here average filter and weighted average filter. So it is used in reduction of the details in an image. All the coefficients are equal. Weighted averaging filter, in this pixel are multiplied by different coefficients. So the center pixel is multiplied by a higher value than the average value. So in this smoothing, two types are there. First one is a mean filter, and the second one is a order statistics. You can see here order statistics. So in this mean, another two types are there. What are that means? That is a average filter and a weighted average filter. So average filter, weighted average filter. So what are the average filters and weighted average filters which are belongs to mean filter, and this mean filter is a one type of spatial filter. So average filter is used in reduction of the details in an image and all the coefficients are equal. Weighted average filter in these pixels are multiplied by different coefficients and the center pixel is multiplied by a higher value than the average value. So these are the mean filters, and second one is a linear filter, second type. So here linear filter in this mean filter. In this mean filter, what are the types? Average filter, weighted average. Another one is a order statistics filter. It is a one type of spatial filter. So order statistics filter, it is based on the ordering the pixels contained in the image area accomplished by the filter. So what is the order statistics filter? It replaces the value of the center pixel with the value determined by the ranking result, and edges are better preserved in this filter. So order statistics means we are going for the mathematical functions we are using here. So it is based on ordering the pixels contained in the image area accomplished by the filter, and it replaces the value of the center pixel with the value determined by the ranking result, and edges are better preserved in this filter. So what are the image, what are the edges are there? So these image edges are preserved. So these edges are preserved the edges. So it is based on the ordering of the pixels contained in the image area encompassed by the filter, and it replaces the order by the pixels contained in the image, and it is determined by the ranking result. Edges are better preserved in this filter. So another types of order statistics filters. What are the subtypes? Minimum filter, maximum filter, median filter. So what is the minimum filter? So the 0th percentile filter is the minimum filter. The value of the center is replaced by the smallest value in the window. And maximum filter, 100th percentile filter is the maximum filter, and the value of the center is replaced by the largest value in the window. Median filter, each pixel in the image is considered, first neighbored pixels are sorted, and original values of the pixels are replaced by the median of the list. So minimum filter, minimum means 0th percentile filter is the minimum filter. So starting of the value 0th, the value of the center is replaced by the smallest value in the window. Maximum filter, 100th percentile filter is the maximum filter. The value of the center is replaced by the largest value. So 100th means maximum filter, means it is replaced with the largest value in the window. Another one is a median filter. It is a difference with median, minimum and maximum. So what is a median filter? Each pixel in the image is considered, first neighborhood pixels are sorted, and the original values of the pixel replaced by the median of the list. So each pixel in the image is considered, first neighborhood pixels are sorted, and the original values of the pixel are replaced by with the median filter. Here these are the replaced with the largest value. Here we are replaced with the median value. Okay, that is the median filter. So order statistics values are the minimum filter, maximum filter, and median filter. So another abbreviation of the smoothing spatial filters are, smoothing filters are used for blurring, for noise reduction. Okay, what are the blurrings are there? These blurrings I am calling as a noise. So we are removing the blurrings, that is the remove noise. So blurring is used in removal of small details, in bridging of small gaps in lines or curves. So smoothing spatial filters include linear filters and non-linear filters. All we have discussed. Spatial filters are two types. That is a linear and non-linear. So in the smoothing spatial filters also two types. That is a linear and non-linear. So linear filter we are calling as a mean filter. Non-linear we are calling as a order statistics filter. So in this linear and non-linear both are included in the smoothing spatial filter. So what is the main aim of the smoothing filter is used to remove the blurrings and noise reduction. So blurring is used for removal of small details and bridging of the gaps in lines or curves. So smoothing spatial filters include linear filters and also non-linear filters. So what is the function? G of x comma y equal to capital T of f of x comma y. So what is g of x comma y? It is the output function, and f of x comma y is the input function. So t is a t is a what is the method I'm using? Okay, so it is a function. So capital output equal to the method. What is a function? That is a capital T of f of x comma y, including with input. So here f of x comma y equal to input image, g of x comma y equal to output image. T is an operation on f defined over the neighborhood of a point x comma y. So it is an operator. So what is the operator I'm using? Suppose I'm using some filter, smoothing filter or spatial filter. Okay, smoothing filter is one operator. Spatial filter is one operator. In the smoothing filter, where some types are there. So which type of filter you are using? Okay, that is called the operator. So output equal to operator of input image. So this operator is nothing but a method or filter type. Method or filter type. So the general implementation for filtering as m into n image with a weighted average filter of the size m into n is given as g of x comma y equal to summation s equal to minus a to a, t equal to minus b to b, w of s comma t, comma f of x plus s comma y plus t divided by s equal to minus a to a, t equal to minus b to b, w of s comma t, where m equal to 2a plus 1, n equal to 2b plus 1. So already we know that g of x comma equal to output function and f of x comma is the input. So w of x comma t is a some filter or operator. So here w of x comma t is a filter function. So a comma t are the limits. Okay, s and a are the x-axis and y-axis coordinates. So here output equal to what is the type of filter, what is the operator you are using. Okay, filter or operator with input function. So m equal to 2a plus 1, n equal to 2b plus 1. It is another equation for spatial filtering. And here it is one example. You can see here it is a 3 by 3 matrix. It is a 3 by 3 matrix. So here 1 by 9 equal to 3 square, 1 by 4 square. So two 3 by 3 smoothing filters are the average masks I'm using here. 2. The constant multiplier in front of each mask is equal to 1 divided by the sum of the values of its coefficients, and it is required to compute an average. So this is the matrix of 3 by 3, that is the average value. So how can you take the average of the two different matrix? That is the filter with mask. The constant multiplier is the front in each mask is equal to 1 divided by the sum of the values of its coefficients are required to compute an average. Okay, it is one example. Another example, it is an example for smoothing spatial filter. It is the original image of size 5 into 5. I am taking it is the original image, that is the input image. So B to F, the results of smoothing filter. So it is the image A, B, C, D, E, F. So image from B to F are the smoothing. So the square averaging filter mask size m equal to 3, 5, 9, 15, 35 respectively. The black squares at the top of the 3, 5, 13, 15 pixels are respective of the borders are 25 pixels apart. So the letters at the bottom range in size from 10 to 24 points in increments of 2 points. The large letter at the top is 60 points. The vertical bars are 5 pixels wide, 100 pixels high, their separation of 20 pixels. The diameter of the circle is 25 pixels and the border is 15 pixels. So how much is a 20% variation of the background image with a 10% noisy image of 550 to 20 pixels. So it is a input image. You can see here it is a blurred image. So that is a, I'm applying some mask here. So we are getting some clarity. That is a output image. So B to F are the smoothing filters. So what is the use of means? From the input to output, what I am applying? I'm applying mask, I'm applying filter to removing the blurrings and noiseless. Okay. So we'll get some clarity of the image, brightness of the image. So it is another example. So first image is a input image. Okay. So it is a input. So the image B is a filtered with a 15 by 15 averaging mask. Okay. It is a mask, applied mask. Okay. Mask technique is applied here. Okay. That is the reason it is showing some blurrings and it is a output image. What is output image means? It is the result of the thresholding original image. Okay. So removed blurrings and noiseless. Okay, and noiseless. So it is another example of the images. Input is a original image. It is a original image and it is a output image, that is a noiseless and removed blurrings and noiseless. Okay. So here I am applying the mask. Another one is a non-linear. So based on ordering or ranking the pixels contained in the filter mask, the replacing the value of the center pixel with the value determined by the ranking result. And examples are median filter, maximum filter, minimum filter. Okay. So non-linear filter based on ordering or ranking of the pixels contained in the filter mask, the replacing the value of the center pixel with the value determined by the ranking result. What are the examples means? Median filter, maximum filter and minimum filters. These are the non-linear filtering. And another one is a X-ray image of circuit board corrupted by the salt and pepper noise reduction with the 3x3 average mask, noise reduction with the 3x3 median filter is the original image. Okay. So I am taking it is the input. So what is the input means? Here salt and pepper noise. It is a salt and pepper noise is there. So second image, what is happening means I am applying the mask technique. Okay. It is a figure A, figure B and figure C. So it is the output. So what is output means? So I am removed the salt and pepper means some brightness adjustment. Okay. Salt means the brightness is very high. Pepper means the brightness is very low. Okay. So I am adjusted the brightness of the image, that is the salt and pepper, and remove the some blurrings are there. So I removed. So what is output means? Brightness adjustment or noiseless with removing the blurrings. Okay. It is one example of use of median filter for noise reduction. Median filter for noise reduction. Another one is a smoothing spatial filter. So here I am using Gaussian mask. I am using one type of mask, that is a Gaussian mask. So what is the use of Gaussian mask? Useful for reducing noise and removing small details. Reducing noise and removing small details. And the elements of the mask must be positive. The elements of the mask must be positive. And mask elements sum to 1 assuming normalized weights, that is divide each weight by the sum of the weights. Okay. That is a 7 by 7. Mask elements sum to 1 assuming normalized weights, that is divide each weight by the sum of the weights. Okay. It is a Gaussian mask with 7 by 7 matrix. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. It is a 7 by 7. So it is one example. It is the input image. It is the output image. Okay. What is output image? Smoothed image. Okay. And what are the common smoothing filters? Averaging, Gaussian, median filter. These are the common smoothing filters. So averaging means linear filter, Gaussian means linear filter, and the median filter is a non-linear filter. So these are the three common smoothing filters. It is one example. 1 by 9 means 3 square, 1 by 5 square, 1 by 7 square. So here I am taking 3. So the size of the image is 3, 5, 7. So here 3 by 3, 5 by 5, 7 means 7 by 7. So here I am taking smoothing spatial filters with 3 by 3 matrix, 5 by 5 matrix, and with 7 by 7 matrix. Okay, with intensity values. So what is a mask size? Determines the degree of smoothing or lossless of the image. Okay, so here it is the input image and it is the output image. So what is the difference means I am adjusted some noiseless. Okay, here input image, output image, input image, output image. So what is the difference means in this outputs images? So we are adjusting. Okay, we removed blurrings and the noise in the B figure B's. Here D, B, D, F. So another example of extract largest or brightness objects. It is a 15 by 15 averaging image thresholding. Okay, so it is the input image. It is the output image. So the input image is there. What is the problem means here? Brightness. So here I am applied the mask. So that is the averaging of the image. So that is a mask technique is applied. That is a averaging, and the output is a image thresholding. Okay, the output is a image thresholding. So okay, the clarity is good. So contrast levels are good in the output image. So the mask weights are samples from 2D Gaussian function. So what is the mask weights of the samples from 2D Gaussian function? So Gaussian function g of x comma y equal to 1 by 2p sigma square exponential of minus of x square plus y square by 2 sigma square. It is a Gaussian function of mask weights. Okay. Here, what is the mask size? Depends on sigma. Okay. So what is the sigma value? Okay. Here, the mask value depends on sigma minus by 0.5 minus by 0.5. Okay. The depends on mask sigma value. The mask size is like this. Okay, it is another example of 7 by 7 Gaussian mask. So these are the intensity values of the pixels. So here the Gaussian function with mask weights, and here the sigma is a mask size. Depends on your sigma value, the size will be changed. So mask size depends on sigma. For example, so here I am taking what is the level of this one? 0.00, 5, 10, 15, 20, 25, 30, 35, 40. I am taking the probability density. Here the sigma values. Okay. Here the sigma values. Mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. So here the sigma values are increasing. Okay. So if and the sigma values are increasing, then the height of this one is also increasing. In the previous also sigma value is increasing, height is increasing. Here also sigma value increasing, the height of this one also mask size is increasing. Okay, so mask size is depends on your sigma value. It is one example, and another example of mask size depends on sigma. It controls the amount of smoothing. Here I am sigma equal to 1.4, sigma equal to 3. So 7 by 7 Gaussian mask. Here 15 by 15 Gaussian mask. So here I am taking 7 by 7. So it is a 15 by 15 mask. So whatever may be, I am taking the sigma value. This sigma value will be depends on your mask size. Okay. Suppose sigma value equal to 1.4 means mask value is 7 by 7. Here I am increasing the sigma value. Then mask size also increased. So 7 is converted to the 15. So it depends on your sigma value. Mask value is changed. So that is the amount of smoothing. It is applied a Gaussian filter is I am applying here. It is another example. It is the input image. So I am dividing as a 2 here. That is a limited smoothing, strong smoothing. Which one you need? What is the requirement? So limited smoothing is a small sigma value. Strong smoothing means large sigma value. Okay. When the sigma value is increasing, then mask size also increasing. When the sigma value is decreasing, then mask size also decreasing. So here small sigma means the mask size is very less. Here the mask value is very high, like this. Okay. Here mask size is 7 by 7. Here mask size is 15 by 15. How means sigma value is increased here, sigma value is decreased here. Okay. So it is another one. It is the input image. It is a box average. It is a Gaussian blurring. Okay. So average filter. Okay. It is a Gaussian blurring. Okay. So noise image. Okay. So this noise image is converted to the output image as a average filter as a noiseless. Okay. So Gaussian blurring means mask. Okay. And the very effective for removing salt and pepper noise is that is a random occurrence of black and white pixels. Okay. So here I'm taking one input pixel. Here I'm taking as a output pixel. So what is the difference? Means in this input and output, the removing of salt and pepper noise. Okay. I'm removing. So salt and peppers are removing. So the random occurrence of black and white pixels are like this. Okay. So black and white pixels are like this. Okay. Black and white pixels are there. So the input image with output image, what is that means? Salt and pepper noise is occurred. So the random occurrence of black and white pixels we are calculating, and the output is with the combination of black and white pixels. So it is another one. It is an averaging of the filter, and it is a median filter. Okay. So averaging filter. It is a median filtering. So smoothing spatial filters with median filtering. Median filter. I am applying this median filter here. So replacing each pixel by the median in neighborhood around the pixel, and the size of the neighborhood controls the amount of smoothing. Okay. So the input image, and it is the enhancing output image. So what is the output image? G of x comma y equal to, so the operator. With input. So the operator with input image. So what is output means? G of x comma y with operator capital T with f of x comma y. So T is the operator on a neighborhood of the pixel. So operator means I'm taking filter. Which type of a filter you are using? Smoothing, sharpening, median filter, or what and maybe which type of filter you are using? Okay, that is the operator. So the input image with intensities of 3 by 3. So the output which with each intensity value. Okay, so it is a sorting of the values. These are the median filter. Okay, when I'm using the median filter, the output is like this. So these are the references. So these are the references of image processing. So already we discussed smoothing spatial filters. So in the smoothing spatial filters, here what is the definition means? The smoothing filter used for blurring noise and reduction of the image. So blurring is a pre-processing step for removing of small details, and noise reduction is accomplished by the blurring. So what are the two types of smoothing filter means? Linear filtering, non-linear filtering. Okay. And median filter is a linear spatial filtering, is simply the average of the filter and contained in the neighborhood of the filter mask. The idea is replacing the value of the every pixel in an image by the averaging of the gray levels in the neighborhood of the pixel, and it is defined by the filter mask, and it is multiplied by higher value than the average value. It is a median filter. And what are the types of mean filters? Averaging filter, weighted average filter. These are the two types of mean filter. So what is average filter means? It is used to reduction of the details in an image. All coefficients are equal, and weighted average filter in these pixels are multiplied by different coefficients, and the center of the pixel multiplied by a higher value than the average filter. So these are the types of mean filter. Another one is a order statistics filter. So it is the second type of filters in smoothing. So what is the order statistic filter? It is based on the ordering the pixels contained in the image area accomplished by the filter. It replaces the value of the center pixel with the value determined by the ranking result. The edges are better preserved in this filtering. And another one is a order statistic filter. It is one type of smoothing filter. So what are the types are there in the order statistics? That is a minimum filter, maximum filter, median filter. What is a median filter? So minimum filter is a 0th percentile filter in the minimum filter. The value of the center is replaced by the smallest value in the window. What is a maximum filter? The 100th percentile filter is the maximum filter. The value of the center is replaced by the largest value in the window. Another one is a median filter. Each pixel in the image is considered first neighborhood pixels are sorted and original values are the pixels are replaced by the median filter of the list. And another one is a smoothing filters are used for removing the noises and blurrings. So blurring is used in removal of small details and bridging of the gaps in lines and curves. So smoothing spatial filters include linear filters and non-linear filters. So what is the function? G of x comma y equal to capital T of f of x comma y. So here f of x comma y equal to input function, g of x comma y equal to output function, and the capital T is an operator, means type of filter. So the general implementation of the filter is a m into n image. It is a weighted average filter, and it is a one example for 1 by 9 into 1 by 16 into, means it is a 1 by 4 square, 1 by 3 square. So 2 into 3 by 3 smoothing averaging filters I am applied. Here another example of original image. So remaining all, removing the blurrings and the noiseless image with the smoothing spatial filter. Okay, it is a input image and it is a masked image, and it is a final output image. Okay, it is a thresholding image. Another is a non-linear filter based on ordering or ranking of the pixels contained in the filter mask. So replacing the value of the center pixels with the value remained by the ranking result. So what are the examples are means median filter, maximum filter, minimum filter. So what are the examples of use of median filter? First, noise reduction. Okay, it is the input image. It is a noise reduction with the 3 by 3 averaging mask. It is the averaging mask. Okay, so output without noise and blurrings. So what are the useful reduction noise and removing of small details? The elements of the mask must be positive. Mask element sum to 1 assuming normalized weights, that is wide each by some weights. It is an example of 7 by 7 Gaussian mask, and it is the input image, that is the original image, and output is a smoothed image. Smoothed image means I am applied the smoothing technique. Okay, that is the averaging a filter. So what are the common smoothing filters? Averaging filter, it is the linear, and the Gaussian filter, it is also in the linear. Median filter is a non-linear filter. So it is one example. 1 by 9 into 1 means 1 by 3 square, 3 by 3 matrix. 1 by 25 means 5 square. 1 by 49 means 7 square. Okay. So 3 by 3, the 5 is there now, 5 by 5 matrix. And here 7 is there, 7 square means 7 by 7 matrix. So mask size determines the degree of smoothing is loss of the details. Okay. Here every image, the mask is applied and noise removing the blurrings and noiseless image. So it is example of extract largest brightness objects are there. Okay. So it is a first image. Okay. It is a masked image. Okay. It is the output image. Okay. The mask weights are sampled by the 2D Gaussian filter. So g of x comma y equal to 1 by 2 pi sigma square equal to exponential of minus x square plus y square by 2 sigma square. Here the sigma value depends on the size of the mask. Here sigma value is increasing means the mask size also increasing. Sigma value decreasing means mask size also decreasing. Here you can see here -5 to 0, 0 to 5. So increasing. The mask size is also increasing. Okay. Here one example of 7 by 7 Gaussian mask. So mask size depends on sigma, for example. So what is one means? So here -3 sigma, -2, minus sigma, plus 2 sigma, plus 3 sigma. So here the sigma values are increasing. Say the mask size also increasing. Here the mask size depends on sigma. It controls the amount of smoothing. So here sigma equal to 1.4, here 3. So are the sigma value increased? Yes. Here 1.4, 7 by 7. Here more than 1.4, that is a 3 here. So that is a 15 by 15. So sigma value is increased, mask size also increasing. Okay. Here sigma decreasing means mask size also decreasing. Okay. It is the input image, it is a small sigma and it is a larger sigma. So when I'm going for the small sigma means limited smoothing, large sigma means strong smoothing. Okay. It is the averaging versus Gaussian. Okay. It is the input image with averaging and it is a Gaussian. Okay. Another one is a median filter, that is a nonlinear, very effective for removing salt and pepper noise. When the image is occurring the salt and pepper noise, we are using this type of median filter. It is a nonlinear. Okay. So it is the first one is a averaging filter, second one is a median filter. Here I am using means remove okay, and smoothing spatial filter means replacing each pixel by the median in a neighborhood around the pixel. The size of the neighborhood controls the amount of smoothing. Okay, it is one example, and these are the list of references. Okay, it is the about of smoothing spatial filter. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.